Hey class, so here's the first of these homework help videos that I'll try to give you guys from time to time. I've had a couple people ask me about question 34 on the homework, and so I thought I'd give you a few pointers since this is a bit of a tricky question. So what we have here is a cycle showing the process of a gas going through an engine, and we're told in the problem statement that the processes from B to C here and from D back up to A here are both adiabatic. So what does that mean? Well, we know since it's adiabatic, that tells us that Q equals 0. Alright, so a key thing to understand then is that the only time that heat is going to be exchanged with the outside environment or with anywhere is either coming in or going out is going to be from A to B and from C to D. Those are the only times where Q is not equal to 0. So what that means then, we can understand then that the heat entering into the engine must take place at the upper part here from A to B. So that means that QH will occur at the process or during the process from A to B. That is a terrible B, so I'll redo it. From A to B, and that QC will occur during the process of C to D. Alright, so when you're asked to determine the efficiency that we're asked for in this question, which we learned in class today is equal to 1 minus the magnitude of QC over the magnitude of QH, we will need to consider the processes of A to B and C to D in order to determine that. But before we're even going to look at the efficiency, we're first asked to determine what type of gas it is, whether it's monatomic, diatomic, or polyatomic. So in order to do that, we must find the gamma value. So we know that P initial times V initial to the gamma is equal to P final times V final to the gamma. So what you need to do is choose 2 points, for example, points D and points A, that we have a change in pressure and volume, where we have a change in both pressure and volume, and we can plug in the values that were given. While they're not actual values, we can go ahead and plug in the ratios that were given and be able to determine gamma nonetheless. So for example, at point A, we know that our initial pressure is P initial, PO, and the volume is V initial. Alright, and then if we wanted to look at, say, P to A, we could also then consider at point D down here that at D our pressure is going to be equal to, let's check here, P initial over 32, and our volume V is going to be equal to 8 times V initial. Alright, and so really, if we're looking at D to A, D would be our initial situation. So this would be P initial and and V initial. And our A position would be the final, so P final and V final. And so we can then plug those in to our relationship here to determine what gamma is. Alright, and then for the efficiency, you're going to have to determine what QH and QC are. Alright, so that's going to be up to you, but as a hint, remember that we've learned that Q is equal to CP times N delta T. Alright, now we're not told anything about delta T. You may be able to back it out from the information given, but most likely you're going to run into trouble since you don't have any numbers. But don't forget, we do have the ideal gas law. So we have NR delta T, that's a delta not a A, delta T is equal to P delta V. Alright, so you can use this, do some substitution in here, and and you should be able to determine what your QH are and QC are in terms of this unknown variable P initial and V initial in our graph. Alright? And then hopefully from that you should still be able to determine what the efficiency is. Give that a shot and let me know if you have any questions.